Hi guys, welcome to today's lesson. So today we're going to be looking at analytical geometry revision. But before that, we're just going to try and look at a quick recap of what we're supposed to know rather with the analytical geometry, and then look at some questions at a later stage that you're going to answer based on that. But for now, let's just look at exactly what is it that we need to do for today. So remember that when we talk about analytical geometry, this is when we have a combination of things from having angles, having lines, and having circles, right? And then when we talk about angles, there's what we call an angle of inclination that we deal with there. And then with the circle, there's two types of situations that we can have. It's when the center is at the origin, or when the center is at any point on the Cartesian plane. With lines, it's a lot of things that we need to remember. Distance of a line, which is the same as length, then the midpoint, which is where the middle point of a certain line, and then a gradient, which is normally the slope of a line. Then from there, equation. Lastly, it will be quadrilaterals, because remember, we do apply analytical geometry a lot in quadrilaterals. Then our key concepts will be the distance, the midpoint, gradient, and equation of a line, as I've just indicated. Now, let's just quickly remember what we need to know. You don't necessarily need to cram these things. Please remember, there's going to be an information sheet that is going to be given to you, right? And the information sheet will be the one that has all of this data. What you just need to know is how to use. So length of a line, remember, it's given by d is equals to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Whereas the midpoint, because this is a point, you do not say m is equals to, because then you're indicating m to be a certain concept. But here, because it's a point which involves x and y, we then include brackets. That's why the formula of a midpoint has what we call brackets. Then you know it will be x1 plus x2 all divided by 2, y1 plus y2 all divided by 2. Now the gradient of a line, remember, it's given by m is equals to. Now please look at the difference here. This is a capital letter M because it means midpoint, but the small letter m, we then use it to represent the gradient of a line, where this is normally change in y over change in x when they summarize it, which is the same as y2 minus y1 over x2 minus x1. Then lastly, we have what we call the equation of a line. And with the equation of a line, remember the m is our gradient, and then the c there will be what we call the y-intercept. And at the y-intercept is when our x value is equal to 0. You know, some concept of functions there that I'm sure by now you still remember. And then we have what you call collinear points. Now with collinear points, these are points that lie on the same straight line. Because they lie on the same straight line, for example, let's say I have A, I have B, and I have C there. Because they are on the same straight line, it means that the slope of the line, if we say, for example, the slope is m is equals to 1 over 2. It means for AB, the slope will still be 1 over 2. Even for BC, the slope will still be 1 over 2. And then definitely, you know, for AC, the slope is 1 over 2. So in simple terms, if points are said to be collinear, we can prove that by showing the concept of gradients, that they have the same gradient throughout that line. So the gradient of AB must be the same as the gradient of BC, which must be the same as the gradient of AC. Not that you must have all three equations, right? Or all three terms that you have here, gradient, gradient, gradient. No, you just choose two. If you're considering AB, you can use AB and maybe BC, or you can use AB and AC, or you can use BC with AC. It doesn't really matter. But the fact that they are collinear, it makes them to have the same gradient. Now let's look at a question that maybe we're going to apply all that we have been told so far. Here they say in the diagram below, A, which we don't know what the coordinates are, but B, which has coordinates -5 and 2, C -3 and 5, are the vertices of a triangle ABC. Now, E is the midpoint of AB. As soon as we know that E is the midpoint of AB, it tells us that we then going to try and use that concept of the midpoint to try and find the coordinates of the unknown point that they gave us, which is A, because we don't know what A is. Remember, that's what we normally use the midpoint for. Either we find the midpoint itself, or we use the midpoint to find unknown angles. So that's what already I am thinking before even going to the questions, because if you go to the questions directly, then you don't have ammunition with you, like maybe a plan of action that this is what they might ask me. Should they ask me that, then I will answer it this way. This is all that needs to happen in your brain while you are trying to read the statement. Anyways, let's just try and see exactly what they will want us to do and then see what we can do with that. Now they're saying here the last thing is DB is perpendicular to the x-axis. So in simple terms, it means that the distance from here to there will be whatever the x value is there, which is -5. So the distance will be 5 units. But let's just see what they want us to do. They say find M, the midpoint of BC. So to find the midpoint of BC, you know this will be M into XC, right? I can just say XC plus XB over 2, and then YC plus YB over 2, right? Or you can say XB plus XC. Remember, plus does not really make much of a difference. So this will be -3 plus -5, all divided by 2, and then here YC will be 5 plus 2 divided by 2, right? And then that is in the brackets there, which is M, and then -3 minus 5 will be -8. This will be -4, and then the midpoint here will be 5 plus 2, which is 7 over 2. That will just be 7 over 2. I will just leave it like that, and that will be the midpoint there. Excuse me. And then give the coordinates of point D, right? As soon as they ask us to give the coordinates, it means already we know what the coordinates are. Remember, I told you that this distance will be 5 units, right? And if that is 5 units, it means that the coordinates of D will be -5, number 1. And then number 2, because this is on the x-axis, it means that y is equal to 0. So this will be -5 and 0. And that's what I will then use as the coordinates of D. Show that the coordinates of A are 7 and -2. Now, what that simply tells us to do is to use the coordinates of E in order to find A, because we know that E is the midpoint, right? So in simple terms, I'm saying x of E, we got it by adding x of A plus the x of B and dividing this by 2, right? And then also the y at E, we got this by adding y at A with y at B and dividing this by 2. Then x at A, we know that will be just x because we don't know it. X at B will be -5. All of this divided by 2, and then x at E, we know this is 1. If I quickly solve for x here, it will be 2 is equals to x minus 5 and then x will be equals to 7. Right? Already you can see I have my x there. And then here it will be 0 is equals to y. Y at b will be 2, so that's plus 2 over 2. And then you work this out, right? So let me just quickly see. Right, yes. So this will then be 2 multiplied by 0 will be 0 is equals to y plus 2, then y is equals to minus 2. And then you can see the coordinates are already there. And then one last question to just quickly look at. They're saying prove that this point does not lie on the line AC, right? If that point was to lie on the line AC, it would have the same gradient as what AC is. So you could simply just say the gradient of AC will be equals to y at C minus y at A over x at C minus x at A. And this will be equals to y at C, we know it to be 5 minus at A, we just found it. Remember we said A was 7 and minus 2, right? So that will be minus 2, all of this divided by x at C is minus 3 minus 7, and this will be equals to 7 over negative 10, right? 7 over negative 10, so it's the same as negative 7 over 10. And then quickly from that, you can then say the gradient of AP, right? The gradient of AP, it must be negative 7 over 10. If not, then it does not lie on it. So let's quickly do that. Y at P will be 1, y at A was negative 2, and then x at P is 2, and then x at A is 7. Already you can see this is going to just give us 3 over negative 4. And that's how you can then prove it. So one way is to find just the gradient of AC and then find the gradient of AP, right? They must be the same, because if P lies on that line, it means they are collinear with one another. Or you can find the gradient of AC, find the equation of AC, and then substitute the point. You will see it won't give you the left-hand side is equals to the right-hand side. But that's a longer way of doing it. But it's one of the ways that you guys can try there. But for now, I want us to take a quick ad break. When we come back, we're going to look at some more questions that have to do with analytical geometry. Please stay tuned. I'll be back just now. Hi guys, welcome back. So we are still looking at the revising analytical geometry, right? So now we're going to look at some more questions that have to do with quadrilaterals now. And then at a later stage, we'll see how we can then adapt some other questions from just past papers that we have out there from everywhere where we can find these resources. So let's just look at it. So if the point A and minus 1 is the midpoint of the line, joining the points X and Y, determine the values of A and B. Now already, what are they telling us? They're telling us that there's X and Y there. There's a midpoint here which is A and minus 1. I might not have shown it up to scale because maybe some length might be longer than, but you understand the point. Then 4 and B. This will be 2 and minus 7. Excuse me. And then from here, you can then see that this distance is going to be equal to that distance, but we're not going to consider the concept of distance here because we have two unknowns, and distance can only work if we have one unknown. So we're going to go straight to using the concept of a midpoint, because they did tell us that this is a midpoint of the line. So that will definitely then mean the x of the midpoint, which I will just call m, will be equals to xx plus the x at y divided by 2. And this is also tells us that the y at m will be equals to the y at x plus the y at y divided by 2. I think I just want to change that y there so that at least there's a difference between the y of a point and the y of a coordinate. So let me just say y like that, right? And then I can then substitute. To substitute, x at m, which is the midpoint, will be the a is equals to the x at x will be 4 plus the x at y will be 2 divided by 2. Already you can see 4 plus 2 is 6 divided by 2 will give me 3. So a is definitely equal to 3. And then with the b value, it will be minus 1 equal to y at x is b plus the y at y is minus 7 divided by 2. All right, now what I'm laughing at is, keep on saying y at y, x at x. It sounds like you are saying the same thing. Anyways, then it will be 2 multiplied by negative 1 there, which will be just negative 2 equals to b minus 7. Then b will be equals to positive 5. And that's how you can then solve that particular question. So that's how you find the value of a and b. Then the second question says a square ABCD. Before I can even read anything about the vertices, I will firstly say what exactly is happening here that I know, right? I know that they're saying the square is ABCD, right? But it can't be like this. The reason why it can't be like this, because the letters needs to follow the order, you see. So that's what I'm trying to say. Before I can even look at the questions, I first need to make sure that I read, I draw my diagram so that I understand what I'm talking about. And then a square, has all the sides equal, right? And then we are being told that now the vertices of this is minus 1 and 6, and then C will be 3 and 6. In simple terms, what they are telling us on a Cartesian plane, if this is 6 here, which is y, the point A will be somewhere there, right? And the point C will be somewhere there. Now let me just bring A closer because it's too far. Let's bring it a bit closer there. And then it means they then say both A and B, B and D, both lie on the line x is equals to 1. So x is equals to 1 is just there. So B will be somewhere there. And then it means D will be somewhere there, right? So this, if you join it, it will then be A, B, C, and then let's just do it like that, right? So this will be A, I know this is B, this is C, and that is D. So already I know that my Y will be negative, my X will be positive there, right? And then my X already we know is 1 because this line lies on 1. My Y already there is going to be, my X is 1, sorry, and then my Y will be positive, which I do not know. But A, I do know this to be minus 1 and 6, and then C, 3 and 6. All right, so since I now know this, I will just erase what I have here, right? So I'm just trying to create more space this side so that I can work this out. Now from there, what do I now know? I know that the midpoint of this line, right, will lie at y is equals to 6. I will just need to find what the y value is, right? And the y value of the x value, the x value from -1 to 3, it will be x is equals to x at A plus the x at C. Now I'm having y in my head, divided by 2, and this will be equals to the x at A, we know that to be -1, plus the x at C to be 3, and then you divide all of this by 2, and it will then give you 2 over 2, which is just 1, right? So it means the coordinates now of the midpoint, it's 1 and 1. So we're going to use 1 is equals to the x at B, which is 1 plus y, 1 plus 1, 1 plus 1, divided by 2, which there's nothing we can really say about that. And then we will then say this one here will be 1 is equals to the x value the y value rather will be y plus a negative y. Do you see? All of this divided by 2. So immediately we know that the distance from -1 to 3 there is 4 units. It means even the distance from y there to that y there will also need to be 4 units. You see? And that's how we then going to inform us, or that's what is going to inform us what the y value is. So from 6 to B there, it must be 2 units, and then from 6 to D there, it must be 2 units. I know this is like a lot of annotation that maybe you might not understanding. So it means this will be the same as 8, and then this will be the same as from 6, if I move 2 units down, I will land at 4. So it is actually going to be 4 instead of a negative number. So B will be 1 and 8. So B will be 1 and 8, and then D will be 1 and 4, right? So I know that the very first thing I thought of us using was, let's use the midpoint, because we know that the midpoint always gives us the coordinates. But here you can see with the midpoint, it does not give you what you want, because then the midpoint will lie on the same line on both the lines, right? It will be 1 and 1, so it will give us like 0 per se. Hence, we do not want that. So we just then gonna use the distance. But if you want to use the midpoint, then we will not treat the other y as a negative. We will treat it as a positive, because then it will be 2y, and then you can work it out. I really, really hope that clarifies a few things, guys, when it comes to the concept of what we just needed to do. Let's just look at one last question. I will guide you through it, and then you guys will be able to then complete this one. Now, quickly here, they say if AB is equals to AD, calculate the value of A. To do that, I will then say, excuse me, I know that AB will be, let me just use the distance formula quickly. So this will be, the distance is the square root of the x at B minus the x at A, all squared, plus the y at B minus the y at A, and then all of this is equals to the square root of the x at D minus x at A squared, plus y at D minus y at A. And this is what you then will use to try and find the value of A. I really hope that this will clarify, just that I don't really have much more time to then complete it, but this is what you will then do to find the value of A. Hi guys, welcome back from the ad break. So I really hope that you got to freshen up a bit with a glass of water, just so that there can be some flow of blood there and you can be a bit hydrated rather there, so that you can be able to look at more analytical geometry. Now we're going to look at the circle analytical geometry, right? This is about the equation of a circle and then also the equation of a tangent to a circle. But firstly, let's look at some keywords that we're going to try and look at, and then later do some questions that have to do with equations of a circle and equation of a tangent. Now, one thing that you need to make sure you are clear on when it comes to circles is the concept of origin, because this is where the coordinates are 0 and 0. So you do need to please make sure you know that, right? And normally it's where the axes are perpendicular to one another. The center will be the midpoint number 1 of the diameter. If this is the diameter, then this will be the radius of the circle, right? And then also the center will be normally where we place the radius from there to the circumference of the circle, right? So that's where the center is actually normally at. Then the radius is then the line that moves from that center to the circumference of the circle. And as I indicated there, it is half the diameter of a circle. Just a quick overview of what you need to be familiar with is we have circles in the Cartesian plane, which one will be the equation of a circle where the center is at any point on the circumference, right? And on the Cartesian plane, I mean. And then the equation is normally given by x minus a all squared plus y minus b all squared equal to r squared. And then these will then be a and b being the center of the circle, and then r being the radius. So you will need to find the square root of that in order to get the radius. So if this is equals to maybe 16, it means r is equals to 4. So the radius of the circle is 4 units. Now, if the center is now at the origin, right, it means this is from x minus a all squared plus y minus b all squared equal to r squared. Remember that I said the a and the b, right, are the coordinates of the center. Since we are saying the center is at the origin, it means this is x minus 0, which is equals to x, and then you square that. It will be y minus 0, which is just y, then you square that, right? So maybe let me just put my squared there. And then the radius, there's nothing that changes there. So this is the same as x squared plus y squared equal to r squared, right? Our center is 0 and 0, and then r is still the radius. That does not change. To try and apply what they've just told us now is, firstly they say determine the equation of the circle with its center at the origin. So immediately I am told that I will know that it's 0 and 0, and the radius is 5 units, so that's r. But because it's the center at the origin, you can just use this equation here that we just spoke about instead of using this equation, which will definitely give you the same answer, just that you will need to substitute, which makes it a bit of a longer calculation. So instead, this will just be x squared plus y squared equals to 5 squared. And then it becomes x squared plus y squared is equals to 25. But if you wanted to use the other equation, it will then be x minus 0 all squared plus y minus 0 all squared equals to 5 squared, you see. And then it will be x squared plus y squared is equals to 25. You see, so it's more or less one and the same thing that we're really going to do there. Now, what if the point that the circle is passing through is minus 2 and 4, but we don't know what the radius is, right? So that simply tells us that x squared plus y squared is equals to r squared. We know that this circle is passing through the point minus 2 and 4, meaning the distance, which is the radius, we can find it by substituting the point minus 2 and 4, which will make it minus 2 all squared plus 4 all squared is equals to r squared. And this will be 4 plus 16 equal r squared. Then r squared will be equals to 20. Then you don't really need to even find the square root there, right? I was actually about to do it, but now that I'm thinking about it, I don't even need to do that. So it will be x squared plus y squared equal to 20. And that will be the equation that we need there. So you don't really need to find the r value, the actual radius, because you are going to square it after all. Then determine the equation with a center at, and then the y-axis is the tangent to the circle. What does that tell us? With this one, we will need to kind of draw a diagram, right? Our center is at 3 and minus 1, so that is somewhere there. And then our y-axis will be the tangent. So it means our circle kind of goes like this. You see, where this is the tangent. And if that's the case, it tells us that these are perpendicular, then the radius will be, since this was 3 and minus 1, the radius will be from there to the point 3 and minus 1, which will make it 3 units. So you see already from that I know x minus a all squared. And then while I'm writing it, I want you to think about why am I now using this one and not the x squared? Yes, I know you thought of it. It's because the center is no longer at the origin, right? And then it's x minus 3 all squared plus y minus 1 all squared. And this is equals to, remember we said our radius is 3 squared. And this becomes x minus 3 all squared plus y plus 1 all squared is equals to 9. And then you would have found the equation there. The diameter AB of a circle has coordinates A, 1, which is 1 and 4, I mean, and then B, which is 7 and 0. What is this? This is a diameter, right? So it means, 1, for us to find the center of the circle, we must find the midpoint of AB, right? And then to find the radius, we will then find, so the radius will then need us to find the distance of AM or the distance of BM, right? If you can do that, then you will know what the center and the radius is. So let's quickly look at the center first. So to find the center, I know this will then be x at A plus x at B divided by 2, and then y at A plus y at B divided by 2. And then from there, I will then say this is the same as x at A is 1 plus 7 over 2. And then this is 4 plus 0 over 2. So in simple terms, I will just say C now, right? In simple terms, our center will just be 4 and 2. Now let me just erase this so that it doesn't make it look like an E, right? And then from there, since I know this, I can find my my radius, or I can just simply say, now let's say x minus 4 all squared plus y minus 2 all squared is equals to r squared. And then we use either the coordinates of A or the coordinates of B. If I use A, it will be 1 and 4. So that will be 1 minus 4 all squared plus it is 4 minus 2 all squared, and this will give me my radius, right? So, and this will simply be 3 squared is 9, then 2 squared will be 4. So that means it's 9 plus 4, which will be 13, and that is equals to r squared. And then I can now write it, I'm just going to write it up there, right? Then my equation will now be x minus 4 squared plus y minus 2 squared is equals to 13. And that's how you can then find the equation of that circle. Now, please understand this. There's a time where the center is at the origin. There's certain things that you need to know there. You can even think of it as just the theorem of Pythagoras, right? X squared plus y squared equal to r squared. Or the center is not at the origin. Then there you definitely need to go with x minus a all squared plus y minus b all squared equal to r squared. From there, I promise you, nothing will ever confuse you with this. Just make sure you remember that diameter is twice the radius of a circle. Therefore, the midpoint of a diameter will be the center of the circle. Guys, let's just quickly take a quick ad break. When I come back, I will then look at one more question that has to do with the circles and try to see how best we can answer that. Please stay tuned. I'll be back just now. Hi guys, welcome back to our lesson. So we are still looking at the analytical geometry revision, right? We looked at everything that had to do with the lines, the angles. Now we're busy with the circles, right? We looked at equation of a circle when the center is at the origin and when the center is at any point on the Cartesian plane. Now we're going to look at some more questions that involve this, where we now need to complete the square and all of that. But let's just look at the very first question that we need to solve. So the question says, given the circle x squared plus y squared plus 6y minus 4x minus 12 equal to 0, you need to determine the coordinate of the center of the circle. As soon as I give you an equation like this, you already need to think to yourself, it means I will need to complete the square, right? I will just write it like that. It means I need to complete the square. So you definitely need to make sure your knowledge of completing the square is on par. And then also that will give us the radius eventually after we do that, right? We know that the completing the square, it's always you multiply by 1 over 2 and then you square, right? You add this on both sides of the equation. So that's the main concept of completing the square. Now, let's look at the equation that we are given. So I'm firstly going to rearrange this. It will be x squared minus 4x plus y squared plus 6y equal to 12. And then from there, it becomes x squared minus 4x, y squared plus 6y equal to, let me just put some space there. I'm going to use a different color. That's why I'm leaving those spaces there for you guys so that you can see what I did in terms of changing this, right? So here it will be plus, now I'm completing the square, minus 4 times 1 over 2 all squared plus, right? And then what I did there, I will also do here. It will be plus, but now it will be the coefficient, this one, which is 6 times 1 over 2 all squared. And then you know, whatever you do on the left-hand side, you must also do on the right-hand side. So it will be plus minus 4 multiplied by 1 over 2 all squared plus 6 multiplied by 1 over 2 all squared. And then I can now simplify this, right? To simplify this, it will be x squared minus 4x plus minus 2 all squared plus y squared plus 6y plus 3 all squared equal to 12 plus minus 2 squared plus 3 squared. And then on the left-hand side, I will have x minus 2 when I factorize that first part, plus when I factorize this one, it will be y plus 3 all squared equal to 12 plus 4 will be 16 plus the 9 there, it will be 25, right? Please just verify for me, right? So this will be 4, we know that this will be 9. If I add all of those, it will definitely be 25. Now, what do I know? I know that my center will be 2 and negative 3, and then I know that my radius will be equals to the square root of 25, which is equals to 5 units. And then prove that the points A and B lie on the circle. To do that, it means if this point lies on the circle, it means when x is negative 2 on this equation, y must be equal to 0. You see, so you can definitely do it like that. Either I would say the easier way will be to just substitute both minus 2 and 0, and then it must give you the left-hand side is equals to the right-hand side, right? If not, then you will know that they don't lie on the circumference. So it will be like minus 2 all squared plus, let's just see if we say 0 squared plus 6 into 0 minus 4 into minus 2 minus 12, this must give us 0, right? And then minus 2 squared, we know this is 4, this is just 0, that's 0. This will be positive 8, so this will be plus 8 minus 12 equal to 0, then it's 0 equals to 0. So automatically you can see that the point does lie on the circumference of this particular circle. And also even with B, you will then, so this was for A, right? For B, you will do the very same thing of substituting. It will be 5 all squared plus 1 all squared plus 6 into 1 minus 4 into 5 minus 12 equal to 0. And then you will see this will also give you 0 is equals to 0 as soon as you simplify this particular question. So please do try that. And that's how you can then show that, or that's how you can prove that they lie on the circle. Or you can just substitute the minus 2 and solve for y, it must give you 0, and substitute the 5 and solve for y, it must give you 1. Now determine the equation of the tangents passing through A and B. Now quickly, I'm gonna firstly draw a diagram for us, right? Just to know what these points are about, right? So remember, A was minus 2 and 0, 5 and 1. So minus 2 and 0, and this was 5 and 1, right? I'm gonna just try and see where I can place. The minus 2 and 0 will be somewhere here, and then 5 and 1 will be somewhere maybe up there, right? And then what do I know? I know that if I have the tangents like this, right? Let me write the proper tangent. When I have tangents like this, right, these will be parallel to each other, right? You can always think about them as being parallel to each other. But since they did not tell us, I will then take it away because I don't want you to then always assume things, right? So if we had been told, then I would use it that way. Please remember what is our center, right? Our center was, I'm just going to go back quickly to find it, it was 2 and minus 3. Right, our center was 2 and minus 3. And then I will need to find 1, the gradient, right, which is the same as m of AC, right? And then with that, it means the gradient of this AC will be y at C minus y at A over x at C minus x at A. And this will definitely be equals to y at C is minus 3, y at A is 0, divided by 2 minus 2. This will simply be minus 3 over 4, right? If that is the case, it means for the tangent, this side it will be for the tangent, right? I will say tan. For the tangent, because they're perpendicular to each other, it will mean the m of this equation will simply just be 4 over 1, a positive 4 over 3, I mean, not over 1. And then the other one, which is for BC, it will be y at C minus y at B divided by x at C minus x at B. And then with this one as well, you do the same thing, minus 3 minus y at B is 1 over x at C was minus 3 minus, okay, I think there was something that we, oh, the x at C is not minus 3, is 2, right? So now I'm seeing that I used 2, now why am I having 3? So this will simply just be 2 minus the y at B will be 1, right? It will be 5. The x at B will be 5. Sorry about that. Now it's confusing me as to which one is y and which one is x. You see, so you just need to quickly try and pay attention to that. So this will be minus 4 over minus 3, which is simply the same as 4 over 3. Do you see? So it means the gradient of the tangent, when it is this, it will be minus 3 over 4. And then you can then use the equation of a straight line, which is y is equals to mx plus c. And then try to find it using those two equations that we have there. So let me quickly do that one for you. To then do this, it means I will then have, remember my first m is 4 over 3, right? I'm going to use this. And then my second m is minus 3 over 4. This goes with b, which I'm going to write the coordinates of there, and this one goes with a, which I'm going to write the coordinates of because I'm going to use them. So minus 2 and 0, 5 and 1. Minus 2 and 0, 5 and 1. And then with this one, it will be y is equals to 4 over 3x plus c. Then I substitute it's 0 is equals to 4 over 3 into minus 2 plus c. Then c will be equals to 8 over 3. Then the equation is y is equals to positive 4 over 3x plus 8 over 3, right? And then with this one here, it will be y is equals to minus 3 over 4x plus c. And then I substitute the coordinates. It will be 1 is equals to 3 over 4 and negative 1 into 5 plus c. And then my c will be equals to 1 plus 15 over 4, which is the same as c is equals to 19 over 4. Then it will be y is equals to minus 3 over 4x plus 19 over 4. And that's what you will then need to do with that particular question. All right, guys, now the summary of what we've looked at, remember to always know how to use the appropriate formulae, and then please go revise the completing of the square, and then always know that the perpendicular is, the tangent is perpendicular to the radius, which I've just used now. All right, guys, that makes us come to the end of our lesson for today. I really, really hope that you did enjoy, but we've come to the end of it, because you know every great thing has an ending. From me to you, mathematics is food for the soul.